Hey everyone, it's really nice to see your faces and I'm super excited to see some of you present and what you have made. So really congrats to you all that you made it so far, and run a big of applause to all of you that did this bootcamp. You're still here, you learned Python yourself, you did this for a few weeks. So big round of applause to start with for yourselves.
Yeah, I'll add it as well.
And good luck all with presenting.
Once again, thank you so much for joining, and it's a great pleasure to see that from 14 teams we have eventually 13 teams. So it's great. And I'm really looking forward to the all presentation. We will be doing in small chunks due to the 40-minute limitation, and as well to give you like 5-minute breaks in between. Okay, so for now, I would like to invite team number 1. So Anita, first please unmute yourself.
Hello.
Yes.
Does everyone
awesome.
hear me?
Yeah, we see you. Great. So really briefly introduce yourself. We know that you are from team 1, and you have your 5 minutes to shine, and don't forget to share your screen.
Of course. So brief introduction. Intro about myself. Anita, and I'm from Toronto, Canada, which is a bit of a different time zone than most of the folks here. And I'm going to share my screen and explore all the data analysis that we've been doing for our Capstone project.
Awesome. Yeah, we see your screen. Thanks.
Okay, awesome. So let me go all the way to the front here. All right, so we decided to go on to 2 different data sets. So first one would be the Oscar Awards, and the Oscar Awards data, like who was nominated for an Oscar Award, who won, and who and types of films that were nominated as well. And then also our second data was the top 10 highest grossing films over a few years, so from 1975 to 2018. So the 5 questions that we decided to explore were these that you'll see here, and I'd like to go into them in detail, but I think you'll have a better understanding of them once I go into our data itself. So at the beginning, we explore our data, and we look at both of our data sets. And then secondly, we analyzed our data frames. We realized that the Oscars data set starts from 1927, so we kind of merged those 2 together based on Oscar data set after 1975, and then also our other data set with the blockbuster films as well. And I'm sure that other teams have done this as well, just to analyze their data, just kind of like merge the 2 together. So this is probably something that's not as important, so I will go over it pretty quickly. What I did find was pretty interesting. So our first question here is, what are the top 3 highest grossing films that have won an Oscar? So what we're looking here is actually those that have actually won an Oscar. What are which films have had the most revenue? And so here we find that Alice in Wonderland, Toy Story, and Pirates of the Caribbean, these kind of lighthearted, and we can kind of make our own assumptions here. There's fantasy, there's comedy and adventure and whatnot. These are kind of the films that we've found here.
Wow.
A second question that we were thinking of was, which genre really earned the most Oscars, right? If that's something that we're aiming for. And so going through our entire data set and looking through the different main genres that were here, and which ones actually earned a Oscar. Plotted a little like visualization just so that we can see. So these are all of the winners of Oscars throughout 1975 to 2008. Most of them tend to be in romance, and then drama and sci-fi, right? Drama and sci-fi are pretty much the same here. And you can see that horror kind of is the last one here. As we all know, there are really some bad horror films that are out there. Our third question that we had was which studios had the best Oscars, right? Into total movies produced ratio. So what we're pretty much, that sentence, that question sounds a little bit confusing, but what I'm trying to say is which studio has the best probability of winning an Oscar compared to the ratio of movies that they produce totally. So what we did was we found the number of movies that they've gotten an Oscar and the total number of movies that they actually produced, right? And then found the percentage of that. So total number of movies won, and then also total number divided by total number of movies that they've produced or got nominated. And so in this, we can see that although Warner Brothers has overall have achieved the most amount of Oscars, they have also produced the most amount of movies in general. So it kind of goes to the saying of like, if you work smarter, if you work harder, there you'll definitely see an increase in winning there, right?
Okay, Anita, I need to cut you off.
Mm-hmm.
Thank you so much. So I'm really curious to see what are the rest of it, because it's really tremendous, especially for like Pixar, Sony Pictures, really interesting results comparison with winners in total. So thank you so much. I will ask you to mute yourself and stop sharing your screen for now. And I want to invite the team number 2, Vivian, if you pronounce it correctly, please.
Hello. It's
Hello.
Vivian. Let me just put the video also. Okay.
Yeah. Hello. Okay.
Hello.
Team number 2.
I'm going to start sharing already.
Okay.
So
yeah.
I'm from team number 2, together with Emily, Johanna, Maria, and Xiaoyan. And like I'm going to show our work. So we used data sets about happiness score. And they also have some measurements like GDP per capita, family, life expectancy, freedom, generosity, trust in government, corruption. So it's just a score based with this, not the actual numbers, a score that made the happiness score. So we had different files for each year. So the first thing we need to do is to merge these files. What we first need to make to put the year in these files, because they don't have a year, of course. And then we saw each year, and as you can see, not every number has the same count. So we could see that the columns names are different. So we need to rename the columns and before merge the data sets, and also the number of entries were also a problem, so we need to investigate it. So that's what we made here. We named all the columns, and then we saw the country names, because the country names sometimes were different. We need to say, for example, Hong Kong was Hong Kong, and then Hong Kong, China. Trinidad and Tobago was with the different E, and also with N, so we need to deal with this kind of thing. So after cleaning everything, we need to also to make sure that the region was in all data sets, because what happened is that in 2 years they have the region, the country and the region, but not not in the last 3 years. So we need to put the regions also in these data sets. So just after this, we made the merge. And then we had this, we can see here in the info. So I'm going to go to the questions already because it's the funniest parts, and it have like beautiful graphs. So the first question was, okay, the happiness score and can be associated with other variables. Which variables interfere more in the happiness score? So here you can see, and I don't think it's a matrix, a heat map or something. So it's near the yellow one. They have more correlation. So you can see like economy, family, health has more relation with the happiness score than freedom, government, and generosity, for example. So yes, that's our conclusion. And this was made with 1 year, and then we made like the same correlation across the years to see if it makes sense. So we saw that the association changed a little bit across the years, but not much. Like, here we have like more details about the things I want to go on. Okay, also we saw like what is the happiest and the least happy regions in the world. What region has the biggest difference between the minimum and the maximum happiness score? Like the countries are so different because the regions have a lot of countries. So that was the idea. So we can see the Australia and New Zealand were the happiest region, and Southern Asia the less happy region. And the Middle East and Northern Africa had the biggest difference. So here we can see, like, we made it was a view not only with the region but the countries. So see, okay, why there's a difference. So we can see like there has some countries with, I know, 6.9, 7, like Israel and United Arab Emirates, but Syria, for example, has a very low maximum number. So we can see like even the same region, the countries have a very different scores. Here you can see by the graphs, you can see like how this is the ranking of the countries. So okay, I'm going to the other one. So this one was very interesting because we want to see if happier countries have higher GDPA, and for this we need to merge with another data set, use a demographic data set that had the actual GDP. So there's another merge made with different problems, of course, but the idea was like the same, to investigate and see if the numbers match and everything. And here you can see they have like a linear relationship between GDP per capita and countries with like in the happiness score of the countries. So yeah, here you can see like more with more detail the answer, but mostly is this. So now we're trying to investigate which countries have more variation happiness score between the years analyzed. So first made like a top 5, like with Venezuela, Benin, Ivory Coast, Togo, in Algeria. But this was made, but we need also to investigate, okay, but how was the difference? Like, was to go better, to go worse? So as you can see, like some countries like Venezuela really dropped in happiness score, and other countries had like get better, like Togo and Benin and Ivory Coast. The other question was how Germany's and Brazil results developed through years. That was because I'm from Brazil and I'm living in Germany, so that was like random. Was like my that was me that I made. That was a question that I made. So first I saw, okay, the happiness score in Brazil was dropping for the years, like was first stable and then drop it. And Germany had like a lift, an increase, and then maintain it. So of course, I made also a lot of some graphs to see like the difference between the other variables to understand, okay, what made this difference. Probably was here you can see like trust governments made some difference. And there's some variables that are a lot of gap between Brazil and Germany, but but family, for example, was almost the same.
Okay, Vivian.
Okay.
Sorry, I need to stop you. It's really interesting, but yeah. So for this one, thank you. I will ask you to mute yourself and stop sharing your screen and switching off your video camera. In the meantime, while I will ask the team number 3 the when to prepare yourself. Just wait when, and in between we'll give a little, like a short feedback on your presentation. Sorry that we skipped it for the first part. I was a little bit more concerned about the time, so sorry. Demi, can you unmute yourself and share a little bit of your thoughts about it?
So for group 1, I thought you did a really nice introduction and explanation on the topics that you did. The layout was very good. And what was also nice is that you did renaming of the data frames. Also, the plots looked very good. You really spent attention on that, which was nice. Maybe you could next time focus more on the renaming of the plots too. So look into the plots and see how you could rename the Ixos and the Ajax. Then the plots would be even better.
Great, thanks. And Demi, can you also add something for the team number 2?
Yeah, of course. Very extensive notebook. Really nice. I missed a bit of a summary above what you were going to do and what you could, what we could expect from your notebook, because it was so extensive. It was a lot of information, which was amazing. Nice use of functions, very good. And then the opposite of group 1 was here. The plots could have more attention. So the plots are very important for your public, especially if you have that much of information around your notebook. So trying to change an agenda here and there, and the Ixos and Ajax were sometimes not readable, which is very important as well. And I missed here and there some comments.
Yeah, thanks, Demi. Thank you so much. Now we switch to Ven. So please unmute yourself. And for a second, I will switch to you, Demi. Okay, so just a second. Okay, stop. I will stop you for a second, Demi, to let Ven present. Okay. Then I, for a second, stop your video and ask you to start your video again.
Okay.
Okay. Okay. Can you start sharing your screen? We'll see whether it was visible for the whole or not. Yeah, we see it. Thank you so much. You can start.
Okay. Good evening, girls. I'm Mo Yang. I'm representing Team 3. And for this capstone, I'm kind of my choice for picking this data set because I work in the energy industry. So I think why not I find something interesting about the industry. And I find the electricity use in the Netherlands. From the graph, you can see that there are main 3 energy companies that supply the whole electricity used for the whole Netherlands, which is Axis, Leander, and Stady. Together, they provide to the near entire countries. And other countries like Westernland and France, they are really representing small part. So this data set will be only taken from the 3 companies. And this market is not really competitive. You can see they are separate very obviously. So in the data, there won't be those overlap parts. And I picked the 3 data set from Cargo, from the 3 companies from this year. And in each data set, there are 14 common variables, which records electricity consumption through the various connection for the particular zip code under the network administrator, which is the energy provider company in the year, this year, of course. So when I reviewing this electricity consumption data, and I come up with this 5 questions, like first one, how many electricity has Amsterdam consumed? For example, Amsterdam is a big city. Okay, then, and we go to my Jupyter notebook. Can you see us?
Yeah.
Can you see me? That's Jupyter. Okay. And first, we read the data from the study, this complete this data set. And I find one issue is like in the net manager, this column, it is numbers compared to other energies data, which they show their company's name here. So I find this is a part I need to work on. And also when I exploring this data set, there is extra column. It should be 14 columns in total for the 3 data set, but there is an extra one I need to drop off. So I started to work on, first I dropped the last column. I use a variable to represent this last column's title, and then use the drop commander to drop this. And then we see it again, the last column being dropped. And then I check the data type, what kind of data are they, and check the data set if there's any missing value, no, false. And check the data set from company Neander, same. 14 columns, this much rows, and data type, no missing values. Same did complete annual access, same. Yeah, no missing values. And then I merge them to one data set. Although there are 14 variables in common, but they have no relationship with it. So I just simply appendix all of them into one. I rename this data frame as merged DF. And then come with my first question. How many electricity has Amsterdam consumed in 2020? Here I find the city in Amsterdam in this total data set, merged DF. And I got all the electricity corresponding to Amsterdam. And then I use a commander to assign to sum it up the column of annual consumption. Then I got the sum of the Amsterdam's annual electricity use, which is this much. And then the second question, I also would like to know which city has consumed the most electricity. So I group by the city based on the city name, and also sum up the annual consumption column, which comes with this column. And then I sort it as ascending force. Then undoubtedly Amsterdam is the first one. Then I want to show in the top city in the bar plot to see which are the 10 cities that consume the most electricity. Oh, the second one is Den Haag. I would thought the second one is Utrecht because it has, yeah, also big population cities. And let's come to question 3. And people in which city are more likely to consume electricity during low tariff hours, which means off their work during weekends. The same, I use the same commander group by city and sum up this variable and got this same command. Oh, it's still Amsterdam again, but which surprises me is that Rotterdam, people in Rotterdam, they tend to use more electricity in their spare time.
Well,
then yeah, Den Haag.
Interesting. And 30 seconds left then. So the last thing you want to share?
Yeah. The last thing I want to share, which country has offered the most net energy consumption? It just simply use consumption times the delivery percentage, then got this. But the final question is, I want to see how many percentage of electricity being consumed by the top cities compared to the whole Netherlands. So I kind of do the research and get this paragraph, which really surprises me. Like Amir is the 5th city who consume this energy. I would expect like a big city like Maastricht or Eindhoven or Groningen, but Amir. But then I realized the data set I took from this year is maybe not that convincing because this year I haven't reached half of it. And I got this data set from Cargo. So there are still a long go to go this year. So which means maybe there are other cities would change this rank. But up till now, I got this conclusion. Thank you.
Thank you so much. I would like to ask you to mute yourself and stop sharing your screen. Yeah, and you can, yeah, I will do this. Thank you so much, then. It's really interesting idea. I love the setting from the beginning. So you gave the really interesting presentation about what are you going to tell about. Then I think it will be a little bit much better if you start your presentation not going step by step how you clean data, what you've done, because everybody was doing this. The most interesting part was to see the findings. So this is really special ones. I mean that, okay, we expect that Amsterdam consumes a lot of energy as a huge city. What was interesting that Rotterdam was consuming a lot of energy during the night and the low tariff. So if you maybe switch off the attention of the presentation first to talking about this more, I think it will be much more interesting. And as well regarding plots, especially the last one, the pie plots, also I think we need to work a little bit on the agenda and how to properly have information located on axis in this case. So thank you for this.
Can I do a little suggestion there as well?
Yeah, sure.
So in terms of visualization of data, pie plots are really, humans are not really good at pie plots. We are way better in bar plots. So if you have the option, it's always better to go for a bar plot. In this case, it was useful, but see how you can always think about, can I use a bar plot instead of a pie plot? We are better in bars instead of circles. That's how we grow as a human species.
Yeah, okay, thank you so much. Now it's time for the team number 5. So I would like Lakshmi to join us. Yeah. Okay.
Hi.
Hello. Yeah, we see you.
Yeah. So I'm Lakshmi Saujanya. I'm speaking on behalf of Team 5. I have Olga and Siham as my team members. Firstly, I would like to thank PyLadies organizers for arranging this bootcamp and running it successfully. So I'll just start with the presentation. So our analysis is based on global malnutrition data. We have taken this data set from Kaggle, and it is from 1983 to 2019 data.
Okay, but please don't forget to share your screen because now we see you.
Oh, sorry.
It's okay. Okay, it's starting. Yeah, we see it. Great, thanks. Yeah. Go.
So let's first see what malnutrition is. It is a serious health condition which occurs in growing children, especially children less than 5 years of age, who don't have good access to good food. So in developing and underdeveloped countries, this is a very serious issue due to lack of food. And there are many organizations like WHO, UNICEF, who are trying to address this issue. So let me just explain what are the different types of malnutrition. We have 5 different types, and we have the data for the 4 types here. Stunting, as you can see in the picture, stunting is a condition in which the person is having low height for their age. Wasting is a condition in which the person is suffering from low weight for their height. Underweight is the condition where they have low weight for their age, and overweight is high weight for their height. So these are the top parameters that indicate malnutrition in a particular country. So this is a brief overview of our data set. The data is collected from the years 1983 to 2019, and this is a global data set. It's collected across 152 countries, and it's observed for children for less than 5 years of age. And as we can see here, these are the top sources of survey. Different organizations conducted different types of surveys, and they made up this data set. The important parameters in the dataset are income classification, wasting, underweight, stunting, and overweight. Income classification is of 4 types. We have it from 0 to 3. 0 is the least income country and 3 is the highest income country. And 1 and 2 are the middle income, the lower income and the upper middle income countries. So these are the 6 questions we considered for analysis. We wanted to see the average proportion of underweight by country's income group. I think I'll just walk through the next slide question by question. The tools and languages which we use to address the above questions are Jupyter Notebook and Python, where we use different libraries like Pandas, NumPy, Matplotlib, and Seaborn. So the first question is, what is the average proportion of underweight by country's income group? So as I said earlier, there are 4 different types of income levels, and we see that the low income level countries have the highest percentage of underweight, which is as high as 23%, whereas the high income countries have a very low percent, which is 3.5%. Coming to the second question, what are the top 5 countries with highest proportion of underweight in 2018? So when we just consider the year 2018, we observe that Niger is the country having the most percentage of underweight population, which is 37.5%. And moving on to the next question, what is the average proportion of all malnutrition types by country's income group? So this is a simple bar graph where for each income type, we want to see the average malnutrition type average here. So for the low income countries, we see that all the parameters are at their peaks except for overweight parameter. So the overweight parameter seems to be increasing as the income level increases, whereas as the income level decreases, the other parameters seem to diminish. And moving on to the next question, what are the top 5 countries with highest proportion of overweight in 2018? So it's observed that Tunisia is having around 17.2% people suffering from overweight in 2018. So we wanted to see how Tunisia has developed over the years in terms of overweight proportion. Between 1985 and 1990, it's been very low. And then there is a slight decrease until mid of 1995 and 2000, but then it again started to increase in a linear proportion until 2019. And then the next question is there a correlation between income group and under and overweight parameters? So we did a small correlation map that indicates the relation between the income type and the overweight and underweight parameters. So we can see that there is a slightly positive correlation between the income type and the overweight. Higher is the income, higher is the possibility of seeing overweight condition among people. And the underweight and income seem to have a negative correlation. So yes, these were the simple analysis we made. And yeah, thank you for this bootcamp. So I would like to show the GitHub code.
Okay.
No, just a second.
Okay. Yes, we see the GitHub. Yeah, it's like 1 minute approximately. Okay.
Yeah, so in the dataset, we have the income levels classified as 0, 1, 2, 3, and they have been converted to categorical variables in order to represent in the table. This is for the first question. And for the second question, we looked upon the year 2018 and gathered information on which countries have the most underweight condition. And for the third question, we basically took the averages and grouped by the income levels and plotted the averages.
Mm-hmm.
And the question 4 is similar to question 2, where we observed the overweight parameter and looked upon the countries suffering from that problem. And we observed that Tunisia and Niger both seem to be the African countries, and they have underweight and overweight conditions. So this is the graph which we used for observing Tunisia.
Mm-hmm.
And yeah, for the correlation, we used the heat map from CPON.
Mm-hmm. Oh, there are some extra. Mm-hmm.
Yeah, and we just did a simple regression plot to see how to see the regression line.
Mm-hmm.
So yes, this is the end of the presentation.
Okay, thank you so much. You can now mute yourself and stop sharing.
Thank you.
Yeah, thank you. Overall, really good one. I really love the way how you presented it. So first you're concentrating on the most important parts, on how you investigate the questions, and then you showed us some code at the end as well. So it's good. What really interesting is the third question, where it was with for the third question, it was when you try to compare the bar plots. Only one thing I was still wondering, maybe Demi, you have an idea what plot can work better there? Because you can still compare that, but it's still, let's say, missing something. Demi, unmute yourself, please.
Yeah, so I shared my feedback in also the group chat. A line graph, I think, would be more insightful. So if you plot the lines, all of them will become more, so you will see if it increases or decreases a bit per country. So I think that maybe made more sense. And yeah, further, really nice with the heat map. One little bit feedback on the rounding of your numbers. In question 1, you did not round, and it was not very insightful if it was a percentage or what it was actually. So it's always useful to put that there or to change it within the graph itself or the table that you made. And the things that you did in question 3, there were a lot of function that you need to use, and sometimes you can really use a function with that. So you define pre-pros in brackets a data frame, and then everything that you do there can be in one function. So you really see that is a pre-processing function.
Yeah, we'll start. First of all, I want to apologize once again for the group number 1, for team number 1, Denikado presentation. Thank you, Demi, for sharing your feedback after the first and second team was spoken. So Anita, thank you so much. You did really tremendous job. For now, I would like to invite team number 6, Lara, to unmute yourself and show yourself and share your screen as well.
Yes, hello everyone. I think you can see me now. So I'm Lara from Team 6, and I was together in a team with Annelies and Carolina. And I'll now share my screen to show you what we have been working on. Can you see it or not? I think I...
Not yet.
No, not yet.
Take your time.
Share another, yeah.
Yeah.
It was just another click there.
We see it. Awesome.
All right. So we are in the Team 6. We found a data set on Kaggle with 120 years of Olympic history of all athletes, the medals they won, the names they have, and those things. And this data set consists of 120 years, and it contains 2 separate data files, actually. First, we prepared everything. We loaded the libraries we need, and we loaded 2 CSVs and merged them. After that, in the preprocessor phase, we scanned for missing values. There were, and we decided to delete the records that had no athlete info at all, or athletes that didn't win medals, because we wanted to focus on the medal winning persons. After that, we replaced the missing values that were there for age with the average. and the weight and the height we changed for the median. And finally, we had to rename, or not really had to, but we renamed the column NOC to country because that's more understandable. Then we looked at the medal winners per gender, and there were far more males than female that won a medal. And I think, but we ran out of time, so we couldn't look into that. But that's probably due to the fact that a long time ago, it wasn't very common for a female to join professional sports. So I think if you would look at the last years, it will be more equal. We also looked at the medal winners per age group, and it's not really surprising that the age group of 20 to 29 has the highest number of medal winners, because then you are really at your best part of life for doing professional sports. We made, or we thought of 5 questions, and I will just go through them one by one with you. In which year did the Netherlands win the most total medals and the most golden medals? There was the most medals in total was in the year 1928, so a really long time ago. I think it was really the year that we had the Olympics in the Netherlands as well. And the most golden medals we won in the year 2008. Then we looked at the most successful Olympic Dutch female and male athletes, and successful means most total medals or the most golden medals. Here we have the results. The person was the female that was most successful was Ankie van Gunstven. She won in total 14 medals, and we have a few women who had all 4 golden medals. And then there was one male, Arie de Jong. I have never heard of him, so I don't know if that's my problem, but he won in total 27 medals. And Charles Ferdinand Pahou de Mortagne, I never heard of him as well. He won 4 golden medals. Were the Netherlands more successful during the Summer or the Winter Olympics? Well, that was definitely the Summer Olympics, because in total we won over 5,000 medals. And even when we corrected for the number of games that were won, it was even the Summer Olympic Games, because that was 178 on average. Then we looked at the ranking where the Netherlands ended in total when you compare it to all the other countries. And at first I did that for all the years, but since it started 120 years ago, it was just too many bars to be able to visualize it. So I narrowed it down to the period of 2000 until 2016. And well, the lower the rank, the better we performed. So in the year 2000, we had really the best position, because we ended at 5th. And our last question was about the sports, the type of sports that was most successful for the Netherlands. As you can see on the left side, it was hockey. We won most medals in hockey, and then rowing and speed skating. On the right, you can see the color of the medals, and there's not really much difference between bronze, gold, and silver. They're all almost alike, the amounts of that. This is as far as the presentation goes. Should I see something of this?
Yeah, you have 30 seconds, so share.
30 seconds, all right. Well, I don't think I'll go into the code. We had a little bit of trouble understanding how it works with different versions. So we have several versions in the GitHub, which this one contains almost everything except for a a few things that are here. So maybe later on we will be able to combine it, but we just ran out of time, and well, we made the best of it.
Yeah, thank you so much for this. Please mute yourself, stop sharing the screen. Okay, Demi, a short feedback.
Yeah, nice presentation. Unfortunately, we not get to look at your code, so I don't really have minuses because it was clear. It was a good presentation. But what you could do better in terms of your pictures, you could use save fig, and it will save your figure as a figure, so you could load it in your presentation. I will share the link to the Stack Overflow in the group chat, where you can see how you do that, so you have nicer pictures in your presentations. And what I really liked afterwards, that you shared your hiccup. I really typed down, you didn't share your hiccup, maybe you can share that next time, but then you shared it, so it was good. So other people can learn from it. And also maybe next time you could share recommendations on what other analysts could do further with your data set. It's always nice to have.
Yeah, great. Thank you so much. I also was really impressed by the analysis, and especially it was really interesting to see the numbers of the medals that won. But the most surprising fact was the number of medals that was won by the Netherlands. I expected cycling actually, but not hockey. So it was really interesting. Okay, yeah. Thanks so much. I would like to invite team number 7, Dani. Can you unmute yourself and start, please? We hear you. Awesome. Good that we hear you. We don't see you yet.
Okay, the video is not working.
Okay, so then share your screen.
Okay. It's because you stopped my video. It says here.
No, I don't do nothing. Try it again, please.
Okay. Because I say you cannot start your video because the host has stopped it.
Oh. I can stop it and start it again. I can say ask to start video. Let's check.
Okay, now. Good.
Awesome. We see you. It's great.
Okay, so I'm going to present in the behalf of my group 7. I'm Danielle. We chose to work on the data set. You're seeing the presentation? Okay.
Yeah. Good? Awesome.
Okay. So we chose just to use the data sets of South Korea and COVID-19. That was a data set that we had already, but I downloaded 2 days ago because it seems that they keep update, and that was from end of May and the 1st of June. The reason why is that for the old data that I have seen until now for the COVID, you don't find a lot about the patient itself, like age, gender, and they even say where they go. So I found that was interesting, and also we tried to explore the weather. Here is the link for the data set, and this data set has 12 CSV files, and we worked on 5 of them. So my first question, it was about if there was a relationship between weather and COVID, because it's something that everybody is talking about, saying that hot weather is bad for COVID and so on. And there are some works that show that there is a relationship. However, we didn't find any relationship. Maybe because we don't have a lot of data points. We have about 500 onset date in the data set. That is the date that the person comes sick, start to have symptoms of COVID. And when we combine, it goes to 200 something, so it's not a lot. And in addition, we know that the COVID is a new disease, and we didn't pass all the weather seasons. So it's difficult to say for sure that there is a relation. We even tried to combine another 2 data sets, the weather with the time province. And as you see, we don't see really a kind of a connection, although you see here about temperature and wind, kind of something in the middle. but not really that show a relationship. And we tried to observe, including the province. So the only thing that we see here is that most of the patients are from one of the province, Daegu, of it, something like this. And the other ones is really no relationship between the weather and the COVID. The second question, we tried to see what was the cause of people getting infected, how they will get infected, considering gender and age. If we check the gender, most of the people, male or female, is because of contact with someone that is sick. And the second reason, overseas inflow. Etc. means that there are a lot of other stuff, so we just don't consider this one as a top position. And about age, the interesting is that usually, again, is about contact with someone of traveling, but of course, old people are not traveling a lot, so they only stay at the top with the contact with somebody. The third question, there was a data set that they kind of make a route of the patient. So you know some place that the patient went. And then we tried to check what are the most visited places for gender and for age. In the case of gender, the first position is hospital. And if you can see, the first 5 positions are almost the same. The only interesting thing is that it seems that the girls are going more to school than the men.
Okay.
And putting everything together about gender and the place that they go, again, we can see very clear that all male, female, the first thing they are going to hospital, but men are going more, and then to stores, and women are going more to the stores. And our fourth question is again about the most visited place, but age. And then we see that usually is about going to the hospital or store for all ages, with exception of the very young ones, the 0 group, and the very old ones, the 80s and the 90s, that they go usually to the hospital or to the pharmacy. And in the case of the 90s, it seems that only the hospital, unfortunately.
Mm-hmm.
And the last question, we wanted to explore a bit of the timeline, because we had a data set that was providing the timeline, and we could combine, sorry, this one we could not combine. We have one about age and one about gender. So what we could see is that usually the group of 20 years old is the one that are most tested. And one thing that everybody already heard about is that as old you are, there is a greater chance for you to die. So you see very clear that the group that is dying more is the one that are older.
Okay.
We can
30
see.
seconds.
Okay.
Yeah,
we can see that the yeah, we can see that the tendency in time is the same, with exception here that at the beginning, people with 70 was dying more than the one of 70s and 80s. And for the sex, for the gender, we have that females are more confirmed, but males die more. And the tendency in the timeline is exactly the same. There is no difference. And the conclusions, I think I don't have time, but it's exactly what we're talking about. So,
okay.
Yes.
Great. Thank you so much. You can stop sharing your screen now. Mute yourself and stop sharing your video. I can stop video. Yeah, great. Thank you. And this, great. Thanks. In the meantime, I would ask to Skiara to be prepared from team number 8. So yeah, thank you so much. I really love that you put conclusion at the end. So it's really, really important one, because a lot of people, don't have time to look through all visualization. They will immediately go through, check the conclusion. If it's something interesting, they will start exploring it. So well done. Also, one short remark about the plots. There were a lot of plots, and actually what I was personally missing a little bit of explanation, because it was a lot of data, a lot of visualization. And what I miss a little bit of, let's say, clarity in this, in the graphics and the diagrams. Demi, would you want to add something?
Yeah, I really like the way how you presented as well. And hi, Danny. It was really nice to see you again. We studied together, so.
Okay.
And yeah, just the conclusions were very good. You really could clearly see that you had a main question to answer. It was around ages, and how you set that out of each other and compared it to each other was really nice. In the first kind of slides, you went with your mouse around things. Hey, maybe I see something there. So there you maybe could put a circle on the presentation. So in order for us to see where you're going, and later on as well. And yeah, naming of the axis could sometimes be better, but yeah. Nice.
Okay, thank you so much. Sciara, can you unmute yourself? Okay.
Yes.
Awesome. Yay, we see you. Yeah, okay, thanks. Okay.
Yes. Perfect.
Yeah.
Yeah, so hey everyone, it's great to be here today. My name is Chiara, and together with my team, Team 8, we did the analysis on the deforestation of the Brazilian Amazon between 1999 and 2019. So to start, we also got our data from Kaggle. We had 3 CSV files, one of the deforestation area in kilometers, another one on the number of fire outbreaks, and another one on 2 weather phenomena taking place in the Amazon. The libraries we used were Pandas, NumPy, SciPy, and Matplotlib. And yeah, we were quite lucky with our data sets because they were already very clean. That was quite handy. And yeah, my other teammates are Marina and Selin. So to start, so question 1 was there a decline or rise in the number of fire outbreaks? And yeah, we used a line plot to show that. And we could clearly see that in the years 2002 to 2010, yeah, that there was an extreme increase in fire outbreaks throughout the whole Amazon. The next question we looked at was which state bears the greatest number of fire outbreaks. There we also looked at the same data set, but we visualized the results in a stacked bar plot. And we can clearly see that the states Mato Grosso and Para were the 2 states, especially between 2002 and 2007, with the most fire outbreaks. But it's also visible that both states yeah, keep having most of the fire outbreaks. Then we also looked at if there is a correlation between the deforestation area and the number of fire outbreaks. And for this question, we had to merge 2 CSV files, the deforestation file and the number of fire outbreaks. And we created a scatter plot. And we were also able to see that there is a positive correlation. Then we looked also at the overall deforestation of all states, whether it was increasing. And yes, here we did a very simple line plot. And we can see that in both 2014 and also since 2017 again, the deforestation is increasing again. And yeah, if we look a little bit further than the data, we can also yeah, connect all these data to all the changes in, for example, politics. And we also looked at, because it's the same graph, whether there have been years where deforestation declined. And we can see that even though it's small, we can see that it happened in 2004, 11, 13, and 16. And then we also looked at the deforestation per state. So there are 8 or 9 states through Brazil that are covered by the Amazon. And we can see that especially the state of Para had a significant increase again in deforestation since 2 years ago. But also Acre and Amazonas have a high increase since 2017. And we can also see that one state, where we will see later on that it decreased again, had a quite significant increase in 2007. But there are luckily some states that also are not exposed to such deforestation, and these are Amapá, Roraima, and Tocantins. And as I said before, in Maranhão, we can luckily see that deforestation has also decreased again. And lastly, we looked at the weather phenomena, so based on severity, how frequent they occurred. And just for your information, we have El Niño and La Niña. And El Niño is actually hot, humid air, and La Niña is cold air. And those weather phenomena basically impact our whole globe. So what happens there in the Amazon is important for all of us. And we could see that, the phenomena were mostly noted as weak and moderate, but we also had some that were strong and even very strong for La Niña and El Niño. And that's it already. Thank you for this opportunity. And if you're interested to see the code, you can have a look at our GitHub.
Thank you so much. Now you can mute yourself and stop sharing your screen. Thank you. Demi, any comments from your side?
Yeah, I think love the color green.
Yeah,
it was nice.
Really great.
It was really nice designed. Only thing for question 5, you could maybe use enrich the legenda, the naming of the states, and the questions were really good answered. I really did not have any feedback on that negatively, so only positively. And maybe to enrich your or deepen your interest in the data set itself or the presentation, maybe you could come up with a why. All the questions were kind of what, and this was maybe a conclusion in why this could happen at some place. So suggestions, hypotheses, something like that.
Yeah, thank you so much. Yeah, and I also love the color as well. So it's really, you immediately see the graphs. It's literally pops up, and it's really good because your attention is go to this graph. So that's what's really good is. Okay, thanks so much. Now I want to introduce team number 9, Yelena.
Hello.
Hello. Yes, we see you. Great. Yes, and we see your screen. Awesome.
Right. So, yeah, thank you for this opportunity to participate in the project. And I've been working with 2 other members, and it's been quite an exciting journey. And yeah, so I have to say that we struggled with the data because we decided to look into COVID-19, and people who try to work with know that it's not easy because it's still being updated as we speak. And so what we wanted to look at is whether, so the data that we used was life expectancy, health indicators. They used the BCG cover, which I'm not going to pronounce that because I'm not sure what's the right way. It's a vaccine was used against tuberculosis, and COVID data from worldometers. So yeah, those are our questions. And whether, so at first we had an idea to go to Mythbusters, because there were a lot of rumors what this vaccine has an effect on coronavirus, and what countries where this vaccine was implemented have a lower rate of infections. And then they decided to have a sub-question whether countries where this vaccine was widely implemented have higher life expectancy. We wanted to see what continents suffered the most from COVID-19 in terms of infected cases and deaths. And yes, we were quite lagging behind because we spent a lot of time clearing the data and just playing with the data. So unfortunately, not all the questions are completed, but it's still work in process. So yeah, so this is our scatter plot for BCG vaccine and life expectancy. And yeah, we don't really see any correlation. And what we see here is what even countries where BCG vaccine was widely implemented, they have lower life expectancy. So, for instance, a country like Afghanistan, where BCG vaccine was highly implemented, still has a very high, very low life expectancy. So it's below 60. And vice versa, countries where vaccine was not implemented, well, with lower coverage, have higher life expectancy. Right. And that the scatter plot. So, so yeah, this is BCG vaccine and COVID. And again, we don't really see any relationship. I mean, it could have been slightly positive, but very weak. And we have outlier, and that's Qatar. So the most COVID-19 affected continent in terms of infected cases and deaths. This is per 1 million of population. So if we look at the moment, Europe is the highest in terms of deaths, and in terms of infected cases, it's North America, primarily US. And yeah, I think I'm
it doesn't look like a COVID.
Remember, this nice time when we needed to describe the lesson with one word. And yeah, just thank you, Phi Ladies, for this opportunity. And it was a really nice journey. And if we realized anything, but there's still a lot to learn. And yeah, but it was very nice to see all other presentations, and it's an inspiration for sure. I mean, some graphs were just extraordinary, and we'll look at the repository. We'll have a look, see whether we can improve our project. But yeah, we needed just a little bit more time.
Yeah.
Okay. Well, thank you, and
okay.
I think that's it from me.
Okay, great. Thank you so much. Traditional, yeah. So stop sharing screen. Thanks. Mute yourself and stop your video. Yeah, great. Thank you. So for now, before getting some feedback, a short introduction. We noticed, I just learned that one team will not, they added their GitHub repo, but they're not going to present. That's why for now we will stop, and then we will start further with Team 10. So Team 10 will be moved to the next time slot. for the next link. And it will start, if I'm not mistaken, in 2030. Just a second. Yeah, and now for the feedback. Yeah, Demi, would you want to start? Or should I?
You can go ahead. Yeah, as well.
Yeah, okay. Oh, from my side was just, it was, I see that it was really, let's say, I know this data set, it's really hard to dig into it. It's literally a lot of time cleaning it, I agree. However, I'd rather spend more time on showing the graphs and telling a story about the graphs than just showing the slide with a lot of questions and spending like the biggest part of the presentation on this question. This is only one tip from my side.
Yeah, and really it's a beginning, and every start is hard, and as long as you learn something from this, it's amazing. The only feedback on the presentation is that in the first kind of questions you had still your index in your table, and you could drop that one for the next time. And also add to your slide that was about millions, where you showed the pie chart.
Yeah.
And yeah, further, don't worry about it. It looked like my first presentation ever I gave as well, so I was really unsure about it. But you don't really have to be unsure. You did good in the sense what you could present. You did really good.
And we will start with team number 10. So I want to welcome Taliana.
Hi everyone. So I am part of the team 10, and Teresa and I have worked in this presentation. So we work with a movies data set. So our timeline is everything you've always wanted to know about movies. This time will be restricted to our questions.
Just a second. Can you maybe get a little bit closer to the mic? Because in the beginning it was really clear, and then it's a little bit like fade away.
Oh, sorry. Can you hear me now?
Yeah.
Okay, wonderful. So, so I was telling you, we use the movies data set that we found in Chicago, and this has around 45,000 entries. So like the earliest movies was in 1888, and they have information up to 2017. And so with this data set, we wonder, okay, what kind of questions can we, what do we want to know? And we found out these questions that we worked on answering. So what movies had the biggest revenues? So we at least knew which one was the first. So if everything went all right, we know who is going to be on top. The second question is, what are the most popular movies of all time? The third one is, the movies with a higher budget receive higher ratings. The other one was, what movies will we recommend based on number of votes and the average votes given? And the last question is, it's mine. I just want to know how profitable are women, a female director, movie, in this case Sofia Coppola, how profitable they are. So if I am a producer, where I can put my money. So let's start. So which are the movies with the highest revenue? This was good. We found Avatar in the first place. So far we are doing fine. So the revenue was $2 billion. So that was a very, very high. And then we have Star Wars: The Force Awakens. So a reminder again, we just have data to 2017. The third one is Titanic. So you can see James Cameron is doing quite good. And we have The Avengers, Jurassic World, and we can have order it according to revenue, not according to profits. And it's not necessarily the one that have with highest revenues have the highest profit. For example, what we can see here, that The Avengers had a lower profit than Jurassic World. Another question we had is, which are the most popular movies of all time? So 2017, of course. We have Minions on the first place, and then Wonder Woman and Beauty and the Beast. And we put here both average about how people found it, if it was good enough. And again, we can see, like, for example, Minions it's very popular, but it's not as good as Wonder Woman, according to what people perceive. So then the question back is like, okay, is there a correlation then between the both average and the popularity? So what people like and what people think is good. So we did a heat map as you can see here. So for example, we had popularity and vote average. That is like from 0 to 10, how good they think they are. So we can see like the correlation is not that high. And if we see popularity and vote count, it's getting like a higher value because it makes sense. More people will go to see this movie if it's popular, and the probability is that more people will also vote on it. And so what else can we see from this heat map? So we can see that the budget and the revenue and the vote count are highly correlated. And of course, you can see here that the revenue and the profit, so makes sense. Of course, it's going to be correlated, right? So we're good here. And we can also see that if a movie has, okay, again, we saw how divided and a higher revenue, the number of votes, and the number, where are we? The number of votes here, and the vote average have no correlation whatsoever. So we use it's something that is called the IMDb, the Johnson Media score, that you can read more about it here in the Wikipedia page. So we use this formula, and we get the score. This is based on the regular users and the number of counts and how they value each movie. So if you want to see good movies, like people that find good, for example, we have the first one is The Shawshank Redemption, then The Godfather, The Dark Knight, and Fight Club. And so if you have like a free on the weekend, you want to see good movies, you have 10 possibilities here. Then our last question was, how profitable have Sophia Coppola's movies been? So I just found like the data that I had on revenue and budget was these 3 movies. So we had that the highest revenue was for Lost in Translation, and then Marie Antoinette, and then lastly, her first film, The Virgin Suicides. So I wanted to see this in a graphical way, so I plot this one. So we can see like the revenue for Lost in Translation was very, very high. So it's a very huge profit. And for Marie Antoinette, it's still like, it's like a $20 million profit. I think it's quite good still. And we have here the last one for The Virgin Suicides.
And it's 30 seconds left.
So, yeah, and this is my last slide. So I hope you enjoyed the presentation and you can play around with your favorite directors as well in our GitHub repo. Thank you.
Okay, thank you so much. I'll ask you to stop sharing your screen, mute yourself. Great, thanks. Yeah, really interesting presentation. From my side, only one comment. You used index everywhere and it was starting from 0. So if you want to say like top 10, you can just mention started from 1 from this side. And regarding the last horizontal like bar chart, I was wondering, it's what a little bit unclear to me. So you show budget and revenue, and I was wondering, so this was such a small budget and then such a big revenue, or the budget was big and the revenue was part of this budget? That was maybe just my readings. Yeah, Demi?
Yeah, to add on that, I think it will be very insightful if you kind of maybe show the percentage of what was the budget compared to the profit. So I think that would give even more insights. With other groups, sometimes it was conclusions next to the slides would be very great to do that as well. There was one slide you talked about popularity, but the sorting was not that way. So maybe you could sort that table. And always make sure to round your numbers in the same way. And I love the funny introduction. Everybody loves funny introductions. They catch attention and those are very great. So that was funny and got my attention.
Okay.
Yeah.
Thanks, Demi. Oh. Okay, I think we got back. Okay, thank you so much. I want to invite the team number 11, Agnieszka.
Yes, hello everyone. My name is Agnieszka and I will, on behalf of Team 11, present our work. I was in a team together with Daniela, Melissa and Alexia. And I will share my screen now. Okay, yeah. Here we go. So we work on the data on mobile applications from Apple Store. We had two CSV files. One was with main data and the other was more focused on descriptions of the applications. And we used several libraries such as Pandas, Matplotlib, Seaborn, and Plotly. Okay, it's not working. Okay. So here we have two data sets we started working with. As you can see, each application had an ID number, which helped a lot with merging. And the first data set included the most important information, and the other one focused on description. Our EDA process, as for most of us, had three stages, so data pre-processing, asking questions, and the actual data analysis. As for data pre-processing, it included reading, merging, and cleaning. And we ended up with a data set with 19 columns, more than 7,000 rows, which means that there were more than 7,000 applications analyzed, 3 different data types, and we've been very lucky with having no missing values. So the cleaning was quite easy. We basically needed to get rid of one column and few duplicates. As for questions, we actually asked 8 questions instead of 5, so I'll try to go pretty quickly through them. The first question was about the distribution of apps per price. And it ended up that most of the applications available in Apple Store are for free or for a very small amount of money. Most of them is below $50, then $50, then 100, and there are just few applications which are a bit more expensive. As for the other question, the second question, we asked about the comparison between the rating of versions. So whether users were more satisfied with the current version of the application or they preferred previous ones. Okay. And it turned out that around more than half of the users, they do not have opinion on that. Actually, they like both versions the same. And then around 23% of users preferred previous versions than the current one. Maybe one of their favorite features was just removed from the current version, or something similar happened. As for the third question, we asked about the number of languages supported in each application. And most applications support just one language. That's more than half of all apps analyzed. Majority of them up to 5 languages, but we managed to find also an application which actually supports 75 languages. That's just one, but it's pretty impressive, I must say. The next question was about applications per category, so per gen, and what percent do they represent. Here again, I was personally expecting games, but didn't know that nearly more than half of the applications in Apple Store are actually games. So it's far more than our other categories. Then we have entertainment, education, photo and video, and utilities. Here, as you can see, the percentage division. Yes, actually, it's 53.7% are games. And then we also ask about the engagement of users with providing feedback on the applications. So with which applications users are the most responsive? They provide feedback and leave comments. And it's, again, games where users were providing the most of the feedback, and the least feedback was found for medical applications. Then we ask about the relationship between the average user rating and average price per category. and use random 10 categories. This graph is actually interactive, so once we have time, maybe in the end I can go, because I would need to switch to my Chrome to show you this graph in interactive format. I think it's pretty interesting. But what we found out is that people pay most in average for medical applications, but they're still not very satisfied with them. It's like mid-satisfaction per the highest price. Shopping apps are for free or very cheap, most probably because they're for selling goods, so people then pay for the products that they buy, and people are users are satisfied with this application as well. So the highest rated applications are music application, but they're also quite expensive. Then we ask about how does the average user rating depend on number of user rating provided. So how does the number of feedback and comments influence the actual rating? So how highly the application is rated. And we found out that for those applications below, we divided all the application into several categories, and with those below 10,000 comments, the rating was the lowest. So depending on the number of feedback, here the actual value was the lowest. For others, it's more equal, as you can see here, but the best for the group between 10,000 and 50,000 comments. Here we prepared a heat map showing correlation between user rating and other variables. And as previously described, there is this very strong correlation between the user rating and the rating of the current version. And mid-range correlation between the number of screenshots showed for display and the rating. So the more screenshots, the better rating is. And in the very end, we analyzed the description part, so the app description, and we prepared a word cloud showing which words are the most commonly used in descriptions. We see its feature, its friend, its word, but also we can see that there are a lot of games there, as there are words such as battle, player, or games themselves.
Okay, 30 seconds. I think if you can manage to show the interaction, the graph.
I think I should be able to manage.
Okay, just make sure that you're sharing the right thing, because now we see on the presentation.
Yes, and I think I need to go to new share, and I should be able to find it. Okay, that's not this. Yes, here we go.
Okay.
So as you can see here, it's interactive. Once you hover over the category, you can see exact numbers. And here is the very small, the medical. But as you can see, the price is the highest, but the rating is mid. Here is the music, so the best rated application for mid price. I really like the format as prepared by my colleague, so it's really interactive. And if we come back to the presentation, I just wanted to end up with saying a big thank you to both my teammates for our work on the presentation, for all the for the audience, for you for hanging up with me, and the biggest thank you, of course, for you PyLadies for organizing this wonderful workshop. And I think I will end here.
Yeah, thank you so much. Yeah, don't forget to mute yourself, switch off your camera. Okay, thanks. Yeah, really great. Really interesting to see this interactive graph. From my only one, what I noticed a little bit work on the graphs, work and as well on the X and Y axis, because some of them were lacking description. It was unclear what is 10 and 5, 10 and 6. And regarding the pie chart, it was as well some, let's say, the numbers where let's cover each other. But I think with, let's say, more exploration about visualization, you will manage to do it. So really, thank you so much. Demi?
Yeah, I think it's really cool that you tried out Plotly, for example, or other libraries. Props on you guys. A few things. you showed that most of the items were, the apps were free. But from that plot, I could not really see it because the bucket was very, very big. It stated like the first 5 or something. So maybe you could separate out the 0, so you could really see that the 0 was. Yeah, you could do that with binning, and then the binning, you can make 0. It doesn't have to be equal in that sense. Yeah, so one slide said that it was supported 75 languages, which is cool, but that graph could get smaller, up to 30, and then you could just state it. Whoa, we found one that was 75, so it made your plot a bit more clean. Yeah, I think that was the most important thing. I was Googling for you how you could share the URL in your Jupyter Notebook. You could do that yourself because you really could use a Jupyter Notebook to share it. You could even go as far as popping up an S3 server or something like that. So Google it. Try to Google how you can present your Jupyter Notebook, or you present your plots on a server. I think it will suit you to do it.
Okay, thank you so much. And now it's time for team 12, Gabriella. Yes. Okay. Oh, yeah. Oh.
Hi, I'm Gabriella. So let me share. Okay.
Now we see the white.
No.
Okay.
Yes. Sorry.
We're expecting that you're going to draw your presentation. Yeah, check the window that you're going to share.
Okay.
Now, yes, that's it. Oh, a lot of movies. Okay, let's go.
So I'm gonna present the Team 12 project, and the team is composed by me and Ken. So we choose the movie database as we know. Okay, as now as TMDB. There we get information about the budget of some movie, revenue, some language, spoken language or original language, and so on. The data set was provided by Kaggle, and there are almost 5,000 of observations. So, okay, the step that we followed was load the data set, data exploration, the initial exploration, ask some questions, clean, merging, and answer that questions. So, okay. With the data exploration, we use some methods like describe and infer to see the missing values, or for example, the mean on the maximum of vote average or vote count. So you realize that the vote average is between 0 and 10. And we also analyze the correlation between the variables. So we saw that vote count has a high correlation with popularity. Yeah, sorry, popularity and the revenue. So with the heat map, we can see with the dark colors the strong correlation between these variables. So it's also possible to see it through the scatter plot, and we see that when the vote count is high, the revenue also probably is high as well, at the same way with popularity. So, okay, as required at least 2 data sets. So we use other data set with the title of the movie. So to get this information, we needed to merge the two data sets through the movie ID. And okay, after the exploration, we worked on the data clean because we realized that some columns was in JSON format. So to be easy to deal with these columns, we converted it in list. Okay, let's go to the question and answers. The first question was, which movies have the highest vote average? So the first 4 moves, we can see that have the high average, and we was so curious about that because it's hard to get the 10 average. So I saw some the vote count, the number of votes, and I realized that these first 4 movies has just 1 or 2 votes. So is this vote average significant? Maybe not. So the next question was about which movies people voted the most. So here we realized that the Inception, The Dark Knight, here is the 10 first movies, and we just listed the vote average just to see if these films has a good vote average, and there is. Oh, and the other question was which movie has the most budget. Okay, in this case, I am not sure if it's correct because I don't know about the currency of this budget, because there are a lot of movies from different countries, and I think maybe it needs to be converted. So I'm not sure about this result. And which movie has the most popularity? Minions was the first one. And about the last question was which production companies have the most movies? Warner Bros., Universal, and Paramount was the 3 first companies. So yeah, that's it. Actually, in the future, I intend to do some visualizations. I didn't work so much on visualization. So that's it. Thank you so much. And if you want to see the code, the repository is here.
Okay, thank you so much. Okay, now you can mute yourself.
Okay.
Great. And stop sharing your screen.
Okay.
Yeah. Okay, good. Thanks a lot. So regarding visualization, thanks for letting us know. And as well, I know there are only 2 people working on this project. So we have teams with 5 participants. We have teams with 2 participants. It's completely different. We even have a team with 1 participant, who's team number 3. So thank you so much. From my side, yeah, just like index, that was a little bit how you say it properly, so it distracts your attention, so in this case. And regarding questions, I think, not regarding questions, I think the really good job with JSON, because this is like what you can usually see in the data sets, and I was really wondering to see how you clean it up, so that's why the next step that we'll do after the presentation ends, I really want to go to the GitHub and check it. Demi, your feedback?
Yeah, I actually had the same things about the JSON file. Nice that you were able to do that. So congrats. And yeah, the questions were clear in that sense.
Okay, good. Thanks. Then I want to invite team number 14, Sushma. Can you unmute yourself? And
yeah.
Okay.
Okay, so can you hear me now?
Yes, and we see you.
Yeah, so hi, my name is Sushma Gautam and I'm representing Team 14. And I will start with a brief introduction. And first, let me first share my screen. And I hope you can see it.
Yeah, we see it. We see
So,
Capstone
yeah.
project. Awesome.
Okay, so we have 3 members in our team, Saihin, Chris, and Sushma, that is me. And we know the task and the Python library we used were pandas, matplotlib, and seaborn. And then, like every team, we faced some initial hiccups and challenges. And initially, the communication was offline. It took some time to get the momentum ready, and also we had some last-minute glitches also today, but we managed to get over them, so that's nice. And the data set that we used is this World Happiness Report, and I noticed that the team 2 has also used it. So apparently movies are not the most popular thing, but people are also interested in knowing that what makes the world happy. And this is a report written by a group of independent experts. So it doesn't represent any official organization like UN or something. And why we chose it, because I think that it has a bit of positive outlook, and we wanted to dig deeper into, what are the things that make people happy. And the questions that we wanted to get answered by analyzing these data sets were which are the most happy countries in the world, which are the least happy, and what are the most significant factors which contribute to the happiness score, and what are the top 10 countries for each criteria or factor. So there is overall score and then independent criteria, and what was the correlation between different factors. And now I will switch to GitHub. I hope you can also see this one.
Not yet. We see your presentation. Check what you're sharing. You can stop sharing and start it again and choose what you want to share.
Yeah. Okay. So.
Yeah, now we see your notebook.
Okay. Okay, great. So yeah, so I will start with here. So the report was based on these 6 measurements or criteria, like GDP, which is related to economy, and then social support, that is like support from family, friends, and the system, and health, like how long people live in different countries, freedom to make life choices, and how generous people are in these countries, and the perception of corruption about the public sector in these public institutions in these countries. So yeah, there were actually many CSV files, but we decided to just take 3 of them because we are quite new and we did not want to get into handling the memory issues and something. So we took the data for 2017, 18, and 19, and we started with analyzing that what are the content, what are the column, and then we experimented with renaming the column to make it more easy to use. And then we wanted to check that how many countries are covered in the data set, and then there were so that comes later, but before starting to thing was that there was no null value, so that made it a bit easier for us. And then there were total 156 countries in the data set, and here is the list of them. And and now comes the analysis of answering the questions that we want to see. So these are the list of top 10 happiest countries in the world, and there is no surprise that the Nordic countries are faring quite well in the list. I think that is quite well known, and like almost half of them are from the Scandinavian countries. And the next question was the least happy countries, and then here is the list of the least happy countries, and we know that most of them are facing some kind of issues or war kind like situation, or so obviously we are scoring a bit less with that. And we wanted to check one particular entry, for example Germany, because I'm living here, and then I see that Germany ranked 17th, and which is not that bad, I would say. And then Yeah, so this overall score was one thing, and then this was the list of top 10 countries who were scoring like from ordered by the score. But then we also wanted to check that which country is scoring the highest for each criteria. So for example, Finland has the highest score overall, but then Iceland has the highest score in terms of social support, and then for example, Qatar has the highest GDP. Yeah, and then coming to the next one, yeah. Now comes the interesting part. So we also wanted to make some drafts for the visualization, and the first one was about plotting top 10 countries for each criteria. So like the one criteria was GDP per capita, and here we see the list of top 10 countries which are scoring the highest in this. So yeah, and so this is for GDP per capita, this is for social support, and everything looks quite fine. I was a bit surprised to check this one particular, this freedom to make life choices, because I would expect that the countries which are listed in a bit lower rank, actually in my view, I thought that they will score higher. So yeah, I'm not really sure that the criteria or how did they calculate the score, but other things they are quite as expected. For like also here the health, about the health or life expectancy, so we can see that the Singapore, Hong Kong, Japan people live quite long in these countries. And there is another so these were the 4 factors, and these are other the remaining 2 factors. And this was also quite interesting, the generosity, because you see the top countries are the countries faring best in these criteria. They are not really developed countries, or they are not are doing quite well, and maybe in some other things, but the people in this country seems to be quite generous, which is great.
Okay.
And
in the 30 seconds.
Yeah. Okay. And then, yeah, we also covered some other things, like how does one particular factor changes the contribution. So maybe like I took the example of economy, which was doing making more, like was more important in 2018, but a bit less in other. And then we also analyzed the relation between different factors, which was already covered by the previous team, so I don't cover it. And yeah, and we also did we also did another can you still see this other notebook?
Yeah.
Okay.
Another
So
one?
just one. Yeah. So the last one. So we also try to merge the database, and we kind of again verified the same thing, that what is the relation between the happiness score and health in those countries. And yeah, obviously the happier you are, the longer you will live. So that's the end of our presentation. And yeah, at the end of this, I would really like to thank you, PyLadies Amsterdam team, for thank you very much for giving us this chance. And I would also like to thank my team for the support, and our mentors, and also the people who are staying to the last presentation. Thank you.
Thank you so much. Demi, what you want to share really, really briefly, because we have less than a minute left. I know that it's too...
Yeah, very impressed by the presentation, and especially by the extensiveness of your notebook. Great use of Lambda. Only thing I could add there is maybe you could use a bit more comments here and there, and a conclusion at the end. Yeah.
Okay, thank you so much. Once again, thank you for all. We have less than 1 minute. That's pretty short. For now, the mentors and we will take a look at your GitHub repo, and in the Bootcamp help channel where you placed it, we will actually give you some feedback. And I thank you thank you mentors who are actually started doing it right now. So, and more information regarding certificates and the next steps will be sent in email for you. Demi?
Great round of applause for every one of you. Thank you so much for being here, and you all did very well. And yeah, it's almost sad to end this here in less than a minute, but great job, all of you. I hope you proceed further in your career with analytics, and if you have any other question, you can always reach out to us. And pay it forward, pay your help forward.
Yeah, great. Thank you so much, Demi, and thank every participant